class. Welcome to a special video that's going to help you to learn to use a little bit of calculus. I don't want you to be frightened. I'm going to teach you some very, very simple but very, very powerful calculus approaches to solving many problems. In this particular set of information, you're going to have to learn 3 rules. And you can write the 3 rules down and you can practice them, and I'm going to show you how to use them. And in the problems we have in this class where you need this, you only need to know the 3 rules. Now, there are actually 10 rules involved in solving first-order derivatives. If you want to go on to get a Ph.D., you'll have to learn all 10. But in this class, you only have to learn 3, and they're very simple ones. And so the first rule is called the addition or subtraction rule. And what we're trying to do here is to simplify an equation down to sort of its essence and try to understand what elements of that equation affect like a 1-unit change. If 1 unit changes, if there's a simple change, how do those elements of that equation impact that change? So we're going to start with a pretty scary equation here. It's not really all that scary once we understand what it is. The pi symbol stands for profit. So we have an equation here that says profit is equal to, and then we have 2 prices, price of party X and the price of party Y. In other words, in this case, we have 2 businesses competing with each other, and they have 2 different prices. So we have this equation, and this equation will give us the profit for, in this case, profit for party X. The first rule for calculus that we're going to learn is the addition and subtraction rule. And what this does is allow us to look at the equation and look for the variable that we're trying to test for. In this case, it's price X, PX. So there's a PX here and a minus sign, and a PX here and a plus sign, and a PX here and a minus sign, and then the number 352 and a minus sign, and then 8PY. Now you'll notice that the last 2 plus addition and subtraction elements do not have a PX in them. So guess what? We don't care about those. So what we're going to do is we're going to eliminate them. So only the addition or subtraction components containing the test variable should remain. Testing for PX, the first 3 components stay. Okay, so there we go. We already got rid of 2 of the 3 components. That's great. Now, here's how we write the formula for doing a multivariate derivative. We have more than 1 variable here. So this is the derivative of the profit with respect to price X. So we're taking a derivative of the profit function with respect to variable PX. Okay. And right now it's equal to just these 3 components. Okay. Now we're ready for the next rule. The next rule is called the power rule. And it applies here because we have PX to the power of 2. PX to the power of 2. We got to deal with that. So how do we do it? If the variable we are testing for has a power, we multiply that power times whatever is being multiplied with the test variable. So 2px squared becomes 4px squared. Okay, there we go. That's it. That's the power rule. And now the last rule, the multiplication rule. The test variable will be reduced by 1 instance, and then we keep whatever was being multiplied times the variable. We get rid of the instance, and the final result is then set equal to 0. So the px here goes away. We subtract 1px from it, so it becomes 60. We have px squared here, so one of those goes away. It becomes minus 4px. And then we have px times py, it just becomes py. And so 60 minus 4px plus py is equal to 0. And we can state that. So having done that, we then have all kinds of things we can do with that result. So let's go through again. We have the addition and subtraction rule. Here, we take each of the components that are being subtracted and add it. And we say, is the variable that we're testing for included in that component? Yes, 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 no, no. We get rid of the ones that don't have the variable we're testing for. Very simple. We then look to see if there's any powers. Yes, there is. We have px squared. So we take whatever this is, it could be a 2, it could be a 3, it could be a 4, whatever, and we multiply that number times whatever is being multiplied times the px squared. So the 2 becomes a 4. And then the multiplication rule, we test to see what's left, and we remove one of the px levels from each of them. So there's 1 here, so it becomes 60. There's 2 here, so it just becomes a 4px. And there's 1 here, so it becomes py. And then we set that equation equal to 0. So that's how we do it. That's not so bad. And if you do this, you're going to be able to solve many problems very, very simply.